All right, so in this case, we're doing exercise number 3 for the practice final exam. So to do this exercise, we're going to use the solver function in Excel, which is in the data tab. But first we need to set up a template that will allow us to make this process easier for us. So let's go ahead and write it down. So input, mailbox, voice, price, David time, Anita time. What does this mean? So basically here they're making mailboxes and toys. They have a price for each. In this case, the mailbox is 8 for each, and the toys is 15 for each. And we have time as another variable. In this case, they both take 1 hour to make each, but Anita takes 3 hours to make the toys. Once we have this, we're gonna go ahead and click here and do the decision variable. So what is the decision variable? Basically, what is the question that we're asking? In this case is how many mailboxes and toys should they produce? So how many? How many? So let's copy and paste this right here. Let's give this some color so we don't forget when we use the solver. So let's go to home, cell styles, neutral. Next, so now we have to do our model. So what's the model or the objective? Well, it says here, maximize the revenue. So we're going to do a revenue model. So maximize revenue for the mailbox, voice, and what is the total as well. So the total will play a big role when you use the solver. So let's give it some color as well. Once we have that, let's build the model. So the model is the price times our demand. Once we have it, we can drag it to the right. This is dynamic, and then for the total, just sum these two. Okay, so last step, we have to do our constraints. This is important. Constraints. This is important for the solver function because it asks us to input the constraints. So let's go ahead and put our value, our operator, and lastly, our constraint. So what are our constraints? It says here that David cannot work more than 5 hours per week and Anita cannot work more than 9 hours per week. So those are our constraints. Let's say David time per week and Anita time per week as well. It says here that it's 5 and 9. So 5 for David, 9 for Anita. It says here that they cannot work more. So cannot work more. So greater or equal. And for the value, we have to use a sum product of the time of David and the demand. Once you have that, you should do the same for Anita. So sum product of the time of Anita and the demand as well. So now we have the template set up. So all we have to do is go to the data tab, click on solver. And once you click on solver, a window will pop up. Here, let's reset this so I can explain a little bit of what's going on here. So what's our objective is to maximize the revenue. So here's the total. And then max, I'm changing the variable cells. So our variable cells is in our decision variable menu. So here, click and drag, select those two. And now for the last part, the constraints. As I told you before, this is a little bit tricky and this is important as well because without the constraints, we cannot do this. So Let's add our constraints. So the first constraint, it's called explicit constraint. So it's the ones that we wrote down here. So since they have the same operator symbol, we can select these two. So this is our value. So reference operator, and this is the constraints. Once we have that, click add. And then that's all the constraints for this exercise. Now for the implicit constraint, as you cannot possibly make any negative mailboxes or toys, you're gonna go ahead and click here. So reference, defer the demand, and change this to this, click on 0. And OK. And once you do that, make sure to click Simplex LP, since this is the type of project we're working with, and then click on solve. Once you do that, it will take 1 to 2 minutes to boot up. So just speed up the process and click on keep solver solution and then on OK. Once you do that, click anywhere on the table. And let's go ahead and reference our answers. So how many mailboxes? 3. How many toys? 2. And what's our total revenue? 54. Okay. And then if you go to the answer sheet, you can see that exercise number 3 has 100% on every single part. See you on the next one.